Welcome to the CADFEM Ansys tutorials. In today's presentation, I'd like to show you how to deal with contacts, and specifically how they're constructed, and how they can be manually generated, for example using concealed selection, and also how they can be generated automatically so as to save time and effort, and then how you can check both automatic and manual contacts. Here we have the rear axle transmission from a tractor, and we're going to look at some of the functions used to model contacts. Starting with visualization of a single contact, we select a single contact and we can see where it's located. All other components in the assembly are only vaguely represented at this stage. Only those components which are involved in this particular contact are represented more clearly. You can see here that there are both red and blue sides to a contact. If a user doesn't like this type of representation, they can of course go to Wireframe Mode so as to see which representation is better or more efficient when it comes to recognizing how this contact is formed. You can now go through each of the individual contacts that have been automatically generated when the geometry was loaded, and in so doing we can observe the form that they take, which can be a bit tedious when there are a lot of components. So there are other methods. For example, I can select a component such as this bolt and, using the right mouse button, in effect say, show me all the contacts belonging to this object. And then I can see there are two contacts, one between the bolt and the cap, the other between the bolt and the transmission housing. Once again, all other contacts are only represented in a vague manner. Furthermore, I can very quickly see where there are contacts between one component and other components. There may be times when I'd like to see where there is contact between two particular components. So in the case of this large assembly, if I wanted to see the contact between the brown and the grey components, then I'd select both components, and using the right mouse button, say Go to Contacts Common to Selected Bodies. In this case, that means this one component, namely contact number 3, which is situated between these two components, and joins them together. There are two ways to generate contacts. First, the manual method. For this, I can go here and select two surfaces. For instance, the underside of the brown component, and also, using the Control key, I can select the upper surface of the grey component. And using the contact function, I can generate a contact between the cap and the housing. This is a quick and efficient way of working when there are just two surfaces, with one situated on one component and another surface on another component. There are other functions that facilitate the inclusion of more surfaces. In this case, we do things the other way round, starting with the function. Right, I want a contact, so I select the related surfaces. So, for example, I select the underside of the brown surface using the Control key, and finish the selection by pressing Apply, and then do the same on the other side. I select one or several surfaces, and then finish the selection, thereby completing definition of the contact. Besides these manually selected contacts, which I'm going to leave behind for now, there are always contacts that have been automatically generated after the geometry has been loaded. These are generated on the basis of the distance between components. This distance is calculated automatically, based on the diagonal of the assembly, which is rather large in this case, so the gap to be bridged here is also rather large until the contact has been generated. I can push the slide bar that regulates when contacts are recognized further to the right, which results in more precise values. Or, rather than using this statistics-based slide bar logic, I can enter a value directly, without use of the slide bar. And, importantly, I once again start automatic contact recognition, and contacts are then made using these settings. If we take another look at a single contact, we see that contact exists between the bolt and the cap, and between the bolt and the lower component, the housing. If we go into Wireframe Mode, we see, yes, there are these two areas, the underside of the bolt head against the surface of the flange, and the cylindrical part down here, which represents the thread. So it's a very efficient method that has to be tackled using the correct tolerances. However, this method enables me to go a lot further in just one step than generating all the contacts manually. So when loading geometry, It always makes sense to be aware of how big the gaps that need bridging are, and to work with this contact detection tolerance, and also to put some effort into finding the correct settings, because overall it really speeds the process up.